Okay, this is the last lesson in chapter 1. So we're going to be rewriting equations and formulas. So what you're going to learn is to rewrite literal equations. Those are equations with more than one variable. We're going to rewrite and use formulas for area and then other common formulas. So an equation that has two or more variables is called a literal equation. And to rewrite a literal equation, solve for one variable in terms of the other variable. So we're still going to use all of the properties that you've used so far. So we'll use inverse operations, addition, subtraction, multiplication, and division properties in order to isolate the variable they specify. So this is what it looks like. We want to solve this equation for y. So they've highlighted it blue in this example. So the first thing you want to do is move the term of 4x. You're going to subtract it from both sides to move it over to the right. Then you will simplify. And then the last step to solve for y is to divide by 3. So you've rewritten it by isolating the variable y. So these can be found in your student journal on page 25. So looking at the first one, the variable y is on the left-hand side of the equation. So we want to move this variable term of negative 2x to the right, so we'll add 2x to both sides. All right, so then we'll get, this is the additive inverse, so it cancels out. Because the 2x and the 15 are not like terms, you're left with an expression, and I like to put the variable x, or the term of x, next to the equal sign, so we're getting it set up already into like a slope-intercept form. You maybe remember that from last year. So this is our answer, the equation solved for y, 2x plus 15. So number 2, again, we're solving for y, so we need to subtract the 4x from both sides. Y is equal to, and again, if we just put that term next to equals, notice that's a positive 2, so that's how we get that plus 2. If you do it just like 2 minus 4x, it's not technically wrong, okay? So just make sure that you're aware of that. All right, on number 3, we're solving for y, and that's all the way over here on the right. So the easiest thing to do would be to subtract 8 from both sides, and we can only subtract it from the like term. So we'll get 5x minus 10 is equal to 5y. Since we're solving for y, the last step is divide by 5, and everything gets divided by 5. Okay? So we'll get, this cancels. X minus 2 is equal to y, and you can leave it like that, or you can rewrite it as y is equal to x minus 2. Okay, sometimes they'll have you solve for a different variable, and there's lots of variables in this equation. You have x, you have y, and you have z. Since we are solving for x in this case, the easiest thing is kind of like to reverse the distributive property, or it's also called factoring. So you can tell that the highlighted blue x is a factor of the 3x term, and it's also a factor of the 5xz. So if we factored that out or reversed the distributive property, we could take 3x divided by x and get 3, and take 5xz and divide by x and get 5z. That's what's left. Then you want to divide both sides by the expression 3 plus 5z, and that'll leave x by itself. So we'll get a chance to try some like this. Continuing in your student journal, and you'll find these problems, 7, 8, 10, and 11. So solving for x. In the first one, we notice that the 10x and the negative 4x are like terms, so we can combine them. So this is going to be equal to y is equal to 6x, but we're solving for x, we want to divide by 6, and that cancels here. So we could rewrite it and say that x is equal to 1 over 6y. leaving it as y divided by 6 would be equivalent as well. Okay, looking at number 8. Here's one just similar to the example that was on the previous slide. We want to factor out that x. So, because x is a factor of the first term, it leaves behind the 3. Actually, let's look a little deeper and we can see that we can factor out 3x because 9 also has a factor of 3. So if we factor out the 3x, we're left with 1 plus 3z. Now we're solving for x, so x is being multiplied to 3 and it's being multiplied to the expression 1 plus 3z, so we could divide both sides by 3 times the quantity 1 plus 3z. And then we can write that q divided by 3 times the quantity 1 plus 3z. Okay. In number 10, now we're going to have variables on both sides. So in number 10, I like to move the variables to the left. You kind of already know that. So I'm going to subtract the 10x from both sides. I'll have y minus 6x is equal to the negative 6. I'll subtract y on both sides. So negative 6x is equal to, we have negative y minus 6, and now I'm dividing by a negative 6, and everything gets divided by the negative 6, both terms. So what we're left with is x is equal to, and when we take a negative 1y divided by negative 6, we have a positive 1 over 6y, and a negative 6 divided by a negative 6 is a positive 1. So there's our equation solved for x. Notice that all we're given in as solutions are expressions, so we're just isolating a different variable when we do this. Okay, in number 11, we are going to solve for x, and so if you can see 2x over here, that's the one we're going to leave behind, so we need to subtract this 2r from its like term. Okay, so we'll have 4g minus r is equal to this negative 2x. So all I have to do is divide by a negative 2, but we don't want to leave a negative in the denominator. So one thing we could do is we could factor out a negative in the top in the numerator and factor out this negative in the denominator. So we would rewrite it to be like negative 4g plus r over 2 is equal to x. And that's how we get rid of that negative in the denominator. All right, so we're going to do the same type of thing when working with a formula. Some of these formulas are very familiar to you. There'd be several area formulas and some interest formulas. So looking at the area formulas, you've got area of a triangle. We're going to solve it for the indicated variable. In number 13, it says, take the area of a triangle and solve for b. So we just have to use inverse operations. The area is equal to 1/2 times b times h. So to the inverse of 1/2 is multiplying both sides times 2. So I would start by multiplying times 2 on both sides. So I would get 2a is equal to, now these 2's canceled, so we have b times h. Since we're solving for b, we simply divide both sides by h. So we'll get b is equal to 2a divided by h. This comes in really handy depending on if you're solving a problem and you need a certain variable isolated. So let's look with the volume of a cone. we have 1/3 times pi times r squared times h. So the first thing I'm going to do is multiply by the reciprocal of 1/3, which is the 3 on both sides. So I'll get 3v is equal to the pi r squared h. Then to undo all of that multiplication, we can divide both sides by pi r squared. So we get h is equal to, because the pi's cancel and the r squared cancels, 3v divided by pi r squared. All right, final problem. It says the amount of money in an account after the simple interest has been earned is given by this formula. A is equal to P plus PRT. P is the principal, R is the annual interest in decimal form, and T is the time in years. So we're going to solve this formula for R. And we're going to start a little bit differently. The first thing we're going to do is subtract this P. Okay, so we'll have A minus P is equal to the P times the R times the T. Now to solve for R, we can simply divide both sides by the principal and the time, the PT. So that we end up with R is equal to our balance, or the amount of money we're left with in the account, minus the principal, all over the principal times the time, and that will give us the rate, and we will solve for a rate. And so this is kind of one of the reasons why we like to rearrange these formulas, because in B it says the amount of money in an account after interest has been earned is 1,080. This is equal to the variable A. The principal is 1,000. That's our variable P, and the time is 2. So the interest rate, right, it's usually in decimal form, but we can also convert it to a percent. So we will start with R is equal to, we have our 1,080 minus our 1,000, and then we'll divide that by 1,000 times 2. So to simplify this, we would get 80 divided by 2,000, and when you divide, you get 0.04, which is equal to 4%. So remember, to change a decimal to a percent, you want to move the decimal place 2 places to the right. So the annual interest rate is 4%.